Okay, this is Math 105, Section 7.4. We're going to talk about basic trig equations. Okay. So a trig equation is an equation that contains a trigonometric function. So here's a few examples. Now the first one is called an identity. That means it's always true, right? The second two are only true for certain values of theta. So 2 sine of theta minus 1 equals 0 and tangent of 2 theta minus 1 equals 0 are true only for certain values of theta. Okay. To solve that trig equation, we find all the values of the variable that makes the equation true. In other words, find all the thetas that make these two equations true. Okay. See, these are true for every theta, right? Sine squared plus cosine squared is always 1. But for these two, we're going to solve for theta. Okay, and we're always going to reduce to solving a basic trig equation, which is this form. In other words, like sine of theta equals c, or cosine of theta equals c, or tangent of theta equals c. So t is a trig function and c is a constant. So we'll get it into simplest form, and then we'll figure out what the theta should be. Okay, so let's look at tangent of theta equals 2. Okay. Find the solutions in one period. Okay. And we can take the inverse tangent of each side of this. So if we take the inverse tangent of both sides of this, we would take this inverse tangent of this side equals inverse tangent of that side, right? So that's how we get this. This becomes theta, right? If we're looking at theta going forward from minus pi over 2 to plus pi over 2. And then theta is inverse tangent of 2. Okay, so we want theta is approximately equal to 1.12 if we're in radian mode. Okay, so that's how we take the inverse tangent of 2. Okay, to do that. Okay, so that's kind of our basic angle where we get a tangent equal to 2. But we have to look at all the angles, since by definition of inverse tangent, the solution is the only solution in the interval minus pi over 2 plus pi over 2. Okay, that interval of length pi, right? So we want to find all the solutions though. Okay, so since tangent has a period pi, we get all solutions by adding integer multiples of pi. Okay, so we can say k is an integer. Okay, and then we're just going to say theta is approximately equal to, because we're using 1.12 radians, plus k pi. Okay, so any multiple of pi, positive or negative, will give us all the angles. Okay, so in this case, we don't want to just give the one solution. We want to give all possible solutions. And because we have a period of pi for tangent, we're going to add multiples of pi, that k pi there. And this is just graphically where those solutions are where tangent is 2. This is tangent, with all its cycles, right? And if we go where y equals 2, we just draw a horizontal line at y equals 2, and we can see it happens at, this was our original solution. This is subtracting pi from our solution. This is adding pi. This is adding 2 pi. This is adding 3 pi. So we get all these solutions. In fact, there's an infinite number of solutions. Okay, and those are the solutions corresponding to k equals minus 1. We go minus pi. K equals 0 is the first solution we got. K equals 1, we go plus pi. K equals 2, we go plus 2 pi, so we get it over here. And then k equals 3, we get plus 3 pi, etc. So we just can, use any integer multiple of pi. Okay, let's look at a couple other examples. Let's say we have 2 sine of theta minus 1 equals 0. Now we're going to solve for sine of theta. So we're going to get everything but sine of theta on one side. Okay, so we add 1 to both sides, and then we divide both sides by 2, and then we get sine of theta equals 1/2. Okay. Now our basic solution to that is theta equals pi over 6. That gives us a sine equal to 1/2. But then we add integer multiples of 2 pi. So that 2k pi we can go forward circles or backward circles. So where k is any integer. So we add all those integer multiples of 2 pi to get all the solutions. Okay. Then we also get this solution, theta equals 5 pi over 6. Because if you go around the circle, you're going to get two solutions. Where our sine is 1/2. Okay, you think about, pi over 6 gives us here, right? But we could also go 5 pi over 6, which is over here. Okay, and that will give us, remember our points here are square root of 3 over 2, 1 half. Our y is 1 half. And our point here is minus square root of 3 over 2, 1 half. So notice the y is 1 half in both of these cases. This is pi over 6 and this is 5 pi over 6. So we go pi over 6, 30 degrees. Or we go 5 pi over 6, which is 150 degrees, and we get the same, sine equal 1 half. Now we also add circles to this, okay? Because, we can go around forward circles or backward circles and at the same point. So we have two basic solutions as we go around the circle once. So that's the idea, is you go around the circle once, and then you get your basic solutions, and then you just add integer multiples of 2 pi to that to get all the solutions. Okay. The part B was tangent squared of theta minus 3 equals 0. We want to get tangent by itself, so we add 3 to both sides. Take the square root of both sides, so tangent of theta equals plus or minus square root of 3. Make sure we have the plus or minus because we took the square root of both sides. Okay, remember tangent has period pi, so we're going to find the solutions in this interval, minus pi over 2 plus pi over 2. And those solutions are theta equals pi over 3 and theta equals minus pi over 3. And you think of it's where the sine is square root of 3 over 2. If tangent is square root of 3, right, then it's where the sine is square root of 3 over 2. So we're going to go up pi over 3 this way, okay, to give us 1 half square root of 3 over 2, okay. And now we're not going to get, now we want to get to minus as well, right? So we can use minus pi over 3 square root of 3, so we can go to minus pi over 3 as well, and that gives us the point 1 half minus square root of 3 over 2. This would give us a tangent of minus square root of 3. So these are kind of our two basic solutions here, pi over 3 and minus pi over 3, and add k pi to each one. Now we could go over here and do it, but if we're, we don't need to go to the second and third quadrant because this takes care of it. We go through our basic cycle, and if we add k pi, add a multiple of pi, that could take us over to, over to here, okay. And if we add k pi to this or subtract k pi, it takes us over here. So that will cover the other two quadrants. So we take our basic solutions, pi over 3, add multiples of pi. Okay, that's the first one. Or minus pi over 3 and add multiples of pi. Okay, and that, remember, this gives us a tangent of theta is the plus square root of 3 for this one. Okay. And for this one, tangent of theta is minus square root of 3. Remember we said it's plus or minus, so because we took the square root of both sides. So those are our two basic solutions, but then we add multiples of pi because that's our cycle for tangent. Okay, here's another example. 2 cosine squared of theta minus 7 cosine of theta plus 3. Now, this is a quadratic type. And what we can do here is we can kind of write cosine as a c. Think of it like a variable. It's not a variable, obviously it's a function, but we can write it like a c, or we can use s for sine or t for tangent too. But we can write it this way, and you can factor that as 2c minus 1 times c minus 3. So if we think of it like a variable, it's, we're factored just like a quadratic. It's a quadratic type. I'm saying c is cosine, and so cosine squared would be c squared. Okay, so then putting it back in our trig form, we have 2 cosine of theta minus 1 equals cosine of theta times cosine of theta minus 3 equals 0. Okay, and then we have two factors. So we set each one to equal to 0. 2 cosine of theta minus 1 equals 0 gives us cosine of theta equals 1 half. And cosine of theta minus 3 equals 0 gives us cosine of theta equals 3. Okay, so these are the two solutions as we go around the circle where our cosine is equal to 1 half. Pi over 3, and then as we keep going forward, it's going to be 5 pi over 3. Because remember, pi over 3, 1, 2, 3 pi over 3, 4, 5 pi over 3. Okay. So that gives us a cosine or an x equal to 1 half. Okay. Okay, so we take those two basic solutions, we're trying to get cosine equal to 1 half, and add multiples of circles, right? So pi over 3 plus 2k pi, and then the other solutions are pi over 3 plus 2k pi. Now we don't have any other solutions because the other one was cosine of theta equals 3, and that's impossible, right? We have no solutions to that. So we only had the cosine of theta equals 1 half as solutions that we could actually get. Okay, here's another one. We have 5 sine of theta cosine of theta plus 4 cosine of theta equals 0. We can use s and c, so we can write it like this. 5s for sine times c plus 4c equals 0. And you can see we can factor out the c there, right? So if we factor out the c, we get c times 5s plus 4 equals 0, right? We're using c for cosine and s for sine. And then just, going back to making them the trig functions, now we have cosine times 5 sine plus 4. 5 sine of theta plus 4, right? It should be a 4 there. Sorry. That should be a 4. Okay. And then we get, so we have two factors, right? Cosine of theta equals 0, or 5 sine of theta plus 4 equals 0. Okay. Cosine of theta equals 0. That would happen at pi over 2 and 3 pi over 2. And then the other one is, if we get sine by itself, it's sine of theta equals minus 0.8 or minus 4/5. Okay. And then we want to solve for sine of theta here. Okay, so for cosine equals 0, we had theta equals pi over 2 and theta equals 3 pi over 2. Okay, as we go through that circle. Okay, and then to find where the sine is minus 0.8, we take the inverse sine, just like we did before. So we would use a calculator for this to get our answer. Try to do it in radians here. Okay. And we do that, we get theta is about minus 0.93 radians. Okay. So the solutions in this interval length 2 pi are theta equals minus 0.93. And then if we go pi plus 0.93, which gives us 4.07, that's going to put us in the third quadrant. Okay, so this is minus 0.93 radians, right? And this is pi. If we go plus 0.93 radians plus pi, we end up over here, right? So there's our other solution as we go around the circle once. Okay, is that we get this one and we get this one. So there's two basic solutions. Okay, which would give us minus 0.93 radians and then plus 0.93 plus pi or 4.07 radians. Okay, taking us here. Okay, so we basically have four basic solutions total for cosine equals 0 and sine equals minus 0.8. Okay, so this one is cosine equals 0. We add circles, 2k pi. These are where sine is minus 0.8 as we go around the circle. Minus 0.93 and 4.07, and we add circles to that. Okay, so that's how we do our solutions for those. So we're going to, in this section, we're going to get all the possible solutions. So we always make sure we add our cycle times an integer. Here our cycle's 2 pi times k, and here 2 pi times k, etc. If we were using tangent, it would be just pi times k, because our cycle is pi.